Hey, welcome to the Metal Activity Series lab. In this lab, you're going to try to prove the Metal Activity Series, which is an organization of how reactive different metals are when compared to each other. And you need to understand the basic rules about these reactions in order to rank the different metals in order of reactivity. So what I've given you here is and you should have gotten this yesterday and read it and annotated it, but I'm going to try to give you a little bit of understanding right now, I hope. Whenever you see an element by itself, a metal by itself, in this case there's iron, the iron is solid and neutral. Whenever you see a metal in a compound like this, for instance, this lead is charged, and it's a cation, and it's dissolved in solution. And so the metals, the solid metals that you're going to be working with today are going to be in these film canisters. And the solutions of metals, or like the lead sulfate, for instance, if you're looking for that, it'll be in a bottle. This one's blue, so I know it's not lead, it's copper. All the copper solutions are blue. All right, now if you put a solution in with a solid and there is a reaction, so you'll see a color change or you'll see bubbles. If you see something happen and there's a reaction, then you know that this element here stole electrons from this one. The one in solution stole electrons from the solid one. Now, if you lose electrons to somebody, that puts you higher on the list than that other element, right? So that makes you more reactive. If you lose electrons in a fight with another element, then that makes you more reactive than that element. In this case, this plus charged lead stole electrons from neutral iron. Now look, the iron dissolved into solution and we'll get solid lead back. All right, now if we reverse this reaction and now we have iron ions in solution in the bottle and we have solid lead, we'll see nothing happens because the iron ions cannot steal electrons from neutral lead because the iron is more reactive. The lead is less reactive, so that means it's holding on to its electrons with greater force than the iron is able to pull. So there will be no reaction in this case. That's how you can make predictions about reactions with the Metal Activity Series. Now you don't have to do all of the tests with all of the metals and all of the solutions. You're just trying to prove that certain metals are more or less reactive than other ones. And you're trying to collect data to prove that the metals you're given today can be ranked. Just rank all of your metals based on their differences in reactivity. This is projected on the screen in the lab right now, and it's the basic rules for how to tell who's more or less reactive. If you're less reactive, then you're going to be lower on the Metal Activity Series that you're making. And that means your solution ions won't, or your solution ions will steal electrons from any solid metal above you. If you're in solution or dissolved and you're lower on the list, you will steal electrons from all the metals above you. Therefore, you will observe a reaction. Here's an example of what I mean by you don't have to do every reaction. In this one, oh, actually, you know what I wanted to do is grab magnesium, not aluminum. All right, this makes more sense. Now I have, in this well, I have a tiny piece of pure magnesium, solid magnesium. in this well, I have a tiny piece of solid copper. And this lab, just like our last lab, materials are going to run out if we use too much of them. So use as little as possible. One piece of each metal and maybe just a drop of the solution. And I put 2 drops in to orient the piece in the right direction. And so what I've done here is I put copper with magnesium ions, and now I have magnesium, solid neutral magnesium with copper cations. And right. Now you can use your glass stirring rod to poke them around and see what happens, but don't cross-contaminate. As soon as you have your sample immersed in that solution, then turn on your water, rinse your stirring rod. Once it's rinsed, you can bring it back to your other reaction. I've waited about a minute here, and I can see that the magnesium is starting to turn black. And as copper ions come out of solution, become solid copper as they steal electrons from the magnesium. So the magnesium is actually dissolving over here, and I'm getting solid copper. Now, my copper, nothing's happening. You only need to do one of these 2 reactions to get the information that magnesium is more reactive than copper and sits higher on the metal activity series. Here, this data would tell us that copper is less reactive than magnesium and sits lower because there's no reaction with solid copper and magnesium ions. Absolutely nothing is happening here. All right, our magnesium piece is getting even more black as we sit here and talk about it. Over time, that color might actually turn a little bit red. And you only need to do one of these tests. If you're testing magnesium versus copper, then use one of the metals and one of the solutions. You don't have to reverse that reaction. For your cleanup today, just like our last lab, or the metals versus nonmetals lab, you're going to come over here to the mat, flip your well plate over, and tap it out, and then take this. If it doesn't come out, you can use your fingers. Just make sure you wash your hands afterwards. And then take your well plate over to the sink, wash it, use the paper towel to dry it, and replace it at your lab station for the next period. Most of the information today can be found out just by seeing how copper 2 chloride reacts differently with these different metals. Of course, we shouldn't see a reaction with copper, and then you can tell if any of these metals should be lower than copper 2 chloride, or copper, on the metal activity series, because if you put any of these solid metals in with copper ions and they don't react, then they're lower than copper. If they do react, they're above copper. And if they react, let's say zinc reacts more than lead, you see it change faster, and the color changes faster. You see more bubbles. If it's more of a violent reaction, then you'll see that zinc would sit higher than lead on the metal activity series, and that's actually true. You can keep track of all of your data here with just pluses or pluses and minuses. If you see a reaction, or if the reaction intensifies, add a plus. And from this information, you should be able to get an initial ranking of your metals. And then the rest of the solutions that you have today, the fine-tuning today can be done with the rest of the solutions if you're not sure. Now, I do have some silver nitrate, but you don't have any silver. I am going to cut up a few pieces of silver today. Hopefully I'll have that available. Ask me if you want to test silver and see where it is. All right, good luck today.